Hi everybody, in this video let's look at refractions. So this is the second video for refractions. So if you haven't watched the first video, you can watch the first video first. Okay, now let's try these questions. In the following diagram, draw the image of trapezium A, B, C, D under the refractions in the line x equal to 8. So this is the axis of refraction. So the questions does not draw the axis of diffraction for us, so we need to draw ourselves. This is y-axis, and here is x-axis. X equal to 8, we look at x-axis. So 8 is over here. So the line mentioned by the questions is actually here. Okay, we draw a line over here first. Okay, so this is the axis of refractions. Let me label it first. Axis of refraction. And the line is x equal to 8. Okay, so the next step is to draw the image. Okay, so we know that the object is over here. The axis of refraction is over here. The image will be over here, right? Okay, let's go through vertex by vertex. Now I'm going to draw the image for vertex A first. So how to draw the image of vertex A is actually very easy. Start from here. Count until the axis of refractions. Okay, 1, 2, 3, 4, 5. Once you reach the axis of refraction, you stop and you remember the number. Okay, let me show you again. 1, 2, 3, 4, 5. Okay, remember 5. Then we start from here, recount it again. 1, 2, 3, 4, 5. Okay, then we stop. This is A prime. This is the image of point A. Okay, we do the same thing for the rest of vertices. So how about B? 1, 2, stop. Start from 0, recount again. 1, 2. Okay, this is B prime. C, 1, 2, 1, 2. C prime. Okay, do the same thing for the last vertex. 1, 2, 3, 4, 5, 6, 7. Okay, stop. Once you reach the axis of diffraction, stop and remember the number. Recount it again from 0. 1, 2, 3, 4, 5, 6, 7. Okay, so this is D prime. Okay, let me write again over here, C prime. Okay, so the next thing is just connect all these points together. Okay, so just connect all these points together, then you will get the image. Oh. Okay, so this is the image of this object. You will notice that they are congruent. They have the same shape, same size, but the orientation is different. So this is A, B, C clockwise. This is A prime, B prime, C prime, and the clockwise. So this is one of the properties of refractions. Okay, now let's proceed to the second questions. In the following diagram, draw the image of this trapezium ABCD under the diffraction in the line y equal to x. Y equal to -2. So now the axis of diffraction is over here. Y equal to x. Y equal to -2. So this is y, this is x. Since the question tells us y equal to -2, we look at y-axis here. -2 will be over here, right? So the axis of refraction will be here. Okay, so this is the axis of refraction. Okay, y equal to -2. Okay, next thing, just do like what I showed you just now. Calculate from one vertex to the axis of diffraction, and then you stop, recalculate again. Okay, let's try one more time. So now I'm going to draw the image of vertex A first. Start from here. 1, 2, 3, 4, 5. Stop and recount it again from 0. 1, 2, 3, 4, 5. Okay, so this is A prime. This is the image of this point. So do the same thing for B. 1, 2, 3, 4, 5. Okay, stop. Remember, just now we counted until 5, right? So recount again, start from 0. 1, 2, 3, 4, 5. This is B prime. Okay, C, 1, stop. 1. Okay, so this is C prime, and do the same thing for the last vertex. 1, okay, stop. Once you reach the axis of diffraction, you stop and you remember the number 1. Okay, start. Calculate again from 0, 1. Okay, so this is D prime. So the next thing, just connect all these points together. Okay, so this is the image of this trapezium. So the first thing, always remember, determine where is the axis of diffractions. Then the second thing, just calculate like what I showed you just now to draw the image of the shape. Okay, now let's proceed to the next questions. Triangle ABC is refracted across the line DE. So this is the axis of refractions. Draw the image of triangle ABC under the transformation. Okay, so you notice that this line is not vertically, it's not a vertical line or a horizontal line. It's go this way. So how do we get the image? You can use your compasses like I showed you in the previous video. So in this case, if, okay, so this one you have to pay attention. If the axis of diffractions is 45 degree like this, okay, for 45 degree like this. Okay, so here's 45 degree, or like this, 45 degree. You can use the method that I'm going to show you here. Okay, so how do we draw this image without using compasses? Some students, they want to count this way. 1, 2, 1, 2, like what I showed you just now. You can get the answer as well. So if you don't want, you can do another way, which I feel is very easy. So you can go this way or go down this way. Okay, 1, 2, 3, 4. Once you reach the axis of refraction, stop and remember the number 4. Now you turn. 1, 2, 3, 4. Okay, so here will be the image for this vertex. So let's say if you don't want to count this way, you want to count this way also can. 1, 2, 3, 4, stop and you turn. 1, 2, 3, 4. You get the same answers. So the point A is 4 on the axis of diffraction. So when you diffract it across this line, the A prime will be still the same place. Will not change the position. Will be the same place. Okay, so how about C? 1, 2, 3, 4, stop. Then turn directions. 1, 2, 3, 4. Okay, so this is C prime. Remember, if you want to count like this, you have to make sure the axis of refractions is 45 degree like this or 45 degree like that. Okay, later I will show you more example. Okay, so the next thing is just connect all these points together. This is the image of this triangle. Okay, so let's try a few other example. Okay, so these are questions that I showed you just now. This, I think I missed out something. Draw the image of triangle under, okay, let me see. Triangle ABC is refracted across the line DE. Draw the image of triangle. Okay, here should have ABC. Triangle ABC under the transformation. Okay, so I have shown you just now. I have shown you just now how to draw it by calculate this way 1, 2, 3, 4, 1, 2, 3, 4, right? Okay, so now let me use this software to show you. So this is the image of this triangle. Still remember what I told you just now. If you want to use the method that I showed you just now, you have to make sure this straight line is 45 degree. So now if I change it to, okay, now I'm going to move this axis of diffraction. Okay, let me try to move it. Okay, so now it's still 45 degree, right? Okay, let me show you how do I use the method that I showed you just now to get the answers. 1, 2, 3, 4, 5, 6. Stop and turn direction. 1, 2, 3, 4, 5, 6. How about this? 1, 2. Stop, turn direction. 1, 2. Okay, so how about this? If you want to calculate this way, you don't have the length of this axis of diffractions. It's not enough long. You can actually extend it if you want. If you don't want, you can do this way. Instead of counting this way, you can go this way. 1, 2, 3, 4, 5, 6. Stop and turn directions. 1, 2, 3, 4, 5, 6. Okay, so now I try to move the axis of diffractions, change to another way. How about this time this way? Okay, so still remember just now what I told you. If you want to use this method, you have to make sure the axis of refraction is 45 degree. Okay, in this case 45 degree like this. Here is 45 degree. Then you can use this method. 1, 2, 3. Stop, turn direction. 1, 2, 3. How about this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Stop, turn direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, do the same thing for the vertex A. But if this is not 45 degree, for example, okay, let me change. Okay, how about do this way? Okay, now look at this. This is not 45 degree, right? Here is not 45 degree. If you do like just now, 1, 2, 3, 4, 5. Stop and turn direction. 1, 2, 3, 4, 5. You will get the wrong answers. So remember, before you want to use the method that I told you just now, make sure this straight line, this axis of refractions is 45 degree. If it is not, you can actually use your compasses to help you to get the answers. Okay, let's try one more question. In the diagram below, triangle ABC is the image of triangle CDE. ABC is a triangle of, okay, I think, hold on. Okay, no problem. In the Okay, let me start again. In the diagram below, triangle ABC is the image of triangle CDE under a refraction in the line PQ. So this is the axis of refraction. So we know that the image and the object, so which one is image? This is image, this is image. ABC, triangle ABC is the image of triangle CDE. So this is object. They are congruent. Same shape, same size, right? So the question is asking, what is the value of x here? X is from here until here. So if this is 30 degrees, since that you notice that all these three lines are parallel to each other, you can use a zigzag alternate angle. Then you know that this is 30 degrees, here will be 30 degrees as well, right? Okay, so the next thing is to try to get the size of this angle. Once we have this angle, we take these two plus together, we get the answer, right? Okay, so this is 30 degrees. Here will be 30 degrees as well because they both are congruent, 30 degrees. So we know that this angle is equal to this angle because these two triangles, they are congruent. So how to get this angle? Angle ACB. The sum of the interior angle of a triangle will be always equal to 180, right? So if I want to get this angle, I take 180 minus 30 minus 68. Okay, so 180 minus 30 minus 68. I will get 82 degrees. This is 82 degrees. If this is 82 degrees, we know here must be 82 degrees as well, right? So x is equal to 82 degrees plus 30 degrees, which will give you 112 degrees. Okay, so this is the way how we get the size of this angle. Okay, so for this video I stop here first. See you next time. Thanks for watching. Bye bye.